Hello friends, in today's question, there is a rectangular plate of mass m of dimension a by b. The plate is hinged and held in horizontal position by striking n small balls uniformly, each of mass m per unit area per unit time. These are striking in the shaded half of region of the plate. The balls are colliding elastically with the velocity v. So we are supposed to find out what will be the velocity of the balls. So this is the hinge plate which is horizontal, and it is kept in this horizontal position by continuously striking the this plate by the balls, and the balls are only in this shaded half of the region. So it means if it is continuously kept in this horizontal position, then the torque which is being produced by the balls which is striking the plate will be equal to the torque which is being produced by the gravitational force. This is the basic concept which we are going to use. So let us first of all find out what will be the torque that will be produced by the balls which are striking only in this shaded half of the region. So for that, let us redraw the figure again. So B is its one dimension and A is the other one, and let us consider a small strip of length dx, of width dx in this shaded region. Okay. So this is our shaded region, and in this shaded region we consider a small strip of width dx which is at a distance x from the hinge. And this distance will be our b minus a. So it is said that the balls are colliding elastically with the velocity v. Therefore we can say as the ball collide elastically therefore the change in momentum for each ball will be equal to minus mv and minus mv, and this will be coming equal to minus of 2 mv, or which we can say simply will be equal to 2 mv. This is the change in momentum for with respect to each ball. Now we consider in the shaded region a strip width dx. Consider a strip of width dx at a distance x from the hinge. Therefore, you can say the area of the strip will be equal to a multiplied by dx, and the number of balls which will be colliding this strip per second will be n multiplied by area of the strip. Thus, the number of balls colliding with the strip per second will be equal to n multiplied by its area. Okay, because it is given they are striking per unit area per unit area per unit time. Okay, so it means for the total area is ndx is adx, so number of balls will be n multiplied by adx. So it means the force which will be acting on the strip will be equal to change in momentum of the elastic balls. You can say force on the strip will be equal to change in the momentum of colliding balls. We can say if the force we represented dF, and then this will be equal to change in momentum is twice mv and multiply by its number of balls n a dx. Therefore, the torque which will be generated by this force thus the torque being generated by this force let us call this as d tau, and it is because of the ball, so let us call this a d tau ball, which will be equal to df at a distance x. So we can substitute value of df. We can say df is our 2mvna dx and multiply by x. Therefore, the total torque we can write it as tau ball will be equal to integration of d tau ball, or which will be integration of 2mvn, sorry I missed a here, this will be a x into dx, and as the torque is acting on shaded area, so its limits is going to start from b minus a and upper limit is b. So we can say this as tau ball will be equal to 2mn av integration of b minus a up till b, and this is x dx. Oh, this is a simple you can say calculation integration. Tau ball will be giving us 2m and av, and this will be x square divided by integration b minus a up till b, and this will be 2. So here 2 and 2 is going to cancel out, and we are going to substitute the limits. So get tau ball is equal to MNAV, and this will be b, upper limit is b square minus b minus a whole square. So we found out the torque which is being generated by the balls. Let us call this equation number 1. You can see this is the torque being generated by the balls striking the shaded area. Striking the shaded area. Next, we are going to find out torque because of the gravity, which will be acting in the downward direction. You can see torque due to gravity. Let us call this as tau gravity, and this will be equal to m g and multiply by the b by 2. This is, let us suppose, is equation number 2. Now it is said that it is being held at horizontal position. Okay. So we can say for horizontal position, the plate should be having rotational equilibrium. Rotational equilibrium, or we can say tau balls should be equal to tau gravity. Now using equation 1 and 2, using equation 1 and 2, we get substituting value. Tau balls is given as MNV b square minus a square whole square, and tau gravity we already know is mg multiplied by b by 2. And here we are supposed to find our velocity. So we can say our velocity is equal to, this will be mgb and 2mnv b square and b square minus a square whole square. And it is also given, already given, that number of balls is 100, mass of the plate is 3. We need to one by one substitute these values. So we get V is equal to 3, G is taken as 10, and B is given as 2, and this is, we have 2, small mass is given as 0.01, number of balls is 100, and width B is our 2 minus 2 minus 1 whole square. So here 2 cancel out with 2, this goes by this, so we are left V is equal to 30 divided by, this will be 4 minus 1, so this will be 30 divided by 3, this cancels out 10, so we can say velocity is equal to 10 meter per second. So this is the velocity of gliding balls. This is the velocity of the balls with which they are colliding elastically with the plate. And another thing, from here we can say that it clearly mentioned that B is 2 and A is 1. Okay. From this we can calculate that this distance will be nothing but B minus A, because it will be at the center. That's why it will be coming as this 1/2 1 and this also 1. So this will be B minus A. Okay. So this completes the question. Thank you.